All right, chapter 6, last chapter review for the cumulative. Draw all necessary markings to show an example of each of the following. So a median goes from a vertex to the opposite side midpoint. So it's kind of estimating here. Let's say that's the midpoint right there. There is a median, if it was actually a straight line. Okay. You could use from any one of them. So let's say the middle's right here. That would also be a median. Let's say the middle's right here. You do not have to draw all three. If this was perfect, we'll talk about that later, but that's a centroid. But you only have to draw one of them. I'm just showing all three. Angle bisector. Any of the angles, like so, you want to split in half. So just draw it to kind of look like it's going through the middle, so that the angles look equal. And you can do that on any of them. I'm not going to do it all three, but pick an angle, make it look like you cut it in half. Real quickly, you don't have to get out a protractor, but don't do something like, whoops, don't do something like this, where that is clearly smaller than that. All right, just kind of make it look like as close as possible to the middle. Mid-segment. A mid-segment connects the two midpoints of two sides, and it's parallel to the third side. So let's say we find the middle here and the middle here approximately. That is the mid-segment. Okay. Again, I'm not going to measure, just try to make it so that this looks equal to that, and this equals that. Perpendicular bisector. Okay. You need the midpoint of a side. Usually it's easier to draw to the bottom. And then a line straight down 90 degrees. It may not come from a vertex, like in this one. And then mark these equal to each other. Okay? So if I had an equal out triangle, then my perpendicular bisector would come from a vertex, but it doesn't have to. All right, each figure shows a triangle with one of its angle bisectors. So it says here angle 1 is 2x plus 8. It says QSR, which is the whole overall angle, is 6x. Be careful, angle 2 is not 6x. I would mark this like so, because many of you on this chapter test wrote 2x plus 8 equals 6x, and it doesn't. It takes two of these to equal 6x. Then you can write 2 times 2x plus 8, or 2x plus 8 plus 2x plus 8. Either way, you're going to get 4x plus 16 equals 6x. I'm going to subtract 4x from both sides and get 6x minus 4x is 2x. Now when I divide by 2, x is 8. And that's all we're finding. Now, if the instruction said find the angles, you would plug this in and find out that each angle is 24. All right, find x if angle 2 is 54x. So 54x. And angle 1 is 55x minus 1. This time you're given both of them, so you just set them equal to each other. 55x minus 1 equals 54x. I'm going to subtract 55x and get negative 1 equals negative 1x. Divide by negative 1, x equals 1, and that's my answer. And again, I could plug in 1 here. Sorry about that. I could plug in 1 here and plug in 1 here and get 54 equals 54 to prove that I got it right. All right, now please look at these pictures. That line is clearly not the same size as that line. So don't say x plus 15 equals x plus 23. In fact, oops, this line is half of this line. So it takes 2 of these to equal the red one. So we write that. 2 of these equals this one. So when I distribute the 2, I get 2x plus 30 equals x plus 23. Subtract x, subtract 30, and I get negative 7. Again, an answer of negative 7 for x is okay. If I plug it in to check, 23 minus 7 is 16. 15 minus 7 is 8. 8 is half of 16. That is correct. All right. Once again, it takes 2 of these to equal this. So I write, sorry, acting up. I write 2 times this is equal to this. So that's going to give me 4x minus 20 is equal to x plus 7. I'm going to subtract x and get 3x, add 20 and get 27, divide by 3, x equals 9. All right, almost there. Each figure shows a triangle with one or more of its medians. All right, so EI is 8. Okay, that means, sorry, read that wrong. It says find EI if JI is 8. So JI is the overarching side. That means HE is a median, so that means this is 4 and 4. So EI is 4. Find DJ if SJ is 12. So SJ, this whole thing, is 12. So the whole line is 12. That means the small piece down here, DJ, is 1/3 of that. So that's 4, and this is twice that. That's 8. So DJ is also 4. Find RQ. We're trying to find the We're trying to find the whole thing. If UQ, this is 5.5. Well, that means this is also 5.5, which means RQ is 11. Okay, here we have JE is 33.3. The whole thing is 33.3. Well, the small piece right here is 1/3 of that. So that's 11.1. Double that makes this 22.2. Add those together, it's 33.3. So WE is 11.1. All right, G is the centroid. So if BE is 12, that's the whole piece again. Then the small piece is 1/3 of that. So 12 divided by 3 is 4. The big piece is 8. What's it asking for? It's asking for BG, which is a small piece, and the big piece, which is 8. Okay. Then it says, if DG is 7, DG is the small piece, The big piece is 14, which is GA. And DA is the whole thing. 14 plus 7 is 21. And last part. Find all these. So perpendicular bisector. Perpendicular, we're looking for a right angle that's also cutting something in half. Well, AB is clearly not cutting anything in half. HD is. Angle bisector. We're looking for an angle that has been split into two equal parts. So we're looking for angle markings. Well, here we have those angles equal. So that makes FC, or CF, my angle bisector. Median is going from a vertex to the opposite side and splitting it in half. Well, A does not have anything from its vertex except that line, which is not inside the shape. E is going this way and splitting this in half. C is going this way, but there's no markings here. So it's EG. Altitude. An altitude goes from an angle, a vertex, okay, to the opposite side at a right angle. Well, from E to here is not a right angle. From C to here is not marked as a right angle. Even though it's outside the triangle, AB is forming a right angle. And last but not least, a midsegment. A midsegment connects two parts of a line of side that are marked equal. So here I have that, here I have this. What is connecting those two? Right there, DG. And that is